the structure of the positive externality problems is quite similar to the structure of the negative externality problems. But let me run you through this positive externality problem. Before I do that, let me tell you something that I probably would forget otherwise. I'm going to go all the way forward to the tabulated welfare effects. So notice here I've got a graph, and I've labeled areas in that graph, and I'm just reporting those areas by letters instead of by calculating the areas of the various shapes in that framework. Usually that's going to be fine. If I ever ask you to do it numerically, I will ask you that. Even then, if you just ran out of time and reported by numbers or by these letters, I would probably just give you full credit. It's not something you're being able to take the area of a triangle isn't something I'm too worried about. All right, let's get back to business. Okay, notice what we have here. We've got this inverse demand curve, but now we're in Wisconsin or someplace where marching band music is really beloved. And so we have a positive externality, same activity, except for the neighbors like the marching band music instead of the other way around. So now our marginal social value function, our marginal private value function is the demand curve, but we have this marginal external benefit. I tend to call these MEV, marginal external value, MEC, marginal external cost. So pardon me if my notation is somewhat different from the books. Anyway, now the marginal private cost is given by 0.5 Q or Q over 2, whatever. And that's going to be the same as the marginal social cost because we've got no negative externality in this state of Wisconsin, this great state of Wisconsin. All right, well, let's do the algebra. So in this situation, we have the, marginal private value, I'm standing and writing, function is 1,000 minus Q. The marginal private cost function, which is equal to the marginal social cost function, is equal to Q over 2. And we have this marginal external, that was strange. Sorry about that interruptions. Anyway, some blue blotch just appeared. Anyway, marginal external value is just constant at 100, and so the marginal social value function is given as 1,100 minus Q, just the sum of marginal external value and marginal private values. So the private market outcome, we just set the marginal private cost and the marginal private value equal to one another. So 1.5 Q is equal to 1,000. So Q is 667. P is 333. And then the socially best, we've got the marginal social value and marginal social cost functions are equal to each other in the socially best case. 1,100 minus Q equals 0.5 Q. So 1.5 Q now equals 1,100, and that means Q is equal to 733. So notice that in this case, the private market outcome fails to produce sufficient quantities of marching band performances, and because of the positive externality. Anyway, that's the real basic case. We graph this. It's pretty straightforward to graph this. Make sure you can do it on your own. Marginal private value function or marginal social value function marginal private cost and marginal social cost are now the same. And then I've got these areas. You can pause it and check out this graph carefully. And then finally, I've got the areas where I've tabulated welfare. And check those if I've made an error. Again, I did this fairly quickly. But you find that the deadweight loss can be eliminated by the optimal subsidy. Here, the optimal subsidy is just 100. You don't, since the positive externality is constant at 100, you don't need to calculate the marginal external value at the socially optimum level to find the subsidy. We had to do that with the cost in the previous screencast because the marginal external cost changed with output. All right, make sure you can do these two problems going into the quiz on Friday, and make sure for all time now you understand the consequences and the way the market fails when there's positive or negative externalities that are large enough to warrant policy intervention. Well, I guess the market can fail, but in such a small way that the costs of intervening to fix the problem are greater than the benefits of doing so, and then we should just leave it be.